Hi guys, welcome to eLecture Online. Today we shall be talking about a crucial topic in Math 101, indices. So I'll be taking you through the basic concepts on how to solve problems using indices. So what is the idea of indices? Now, indices is a plural form of a word that is gotten from the word index. So let me explain that mathematically. If I have and this expression a raised to the power of m. Now, this simply means when you look at this very well, a is called the integer and m is called the index. A is called an integer and m is called an index. And this index can assume a natural number, can assume a natural number. And this integer, from the word integer, is it can be uh, a negative or a positive whole number. So in this series, I'll be showing you how to solve simple valued problems using indices. But now, in order to understand the concept of this topic accurately, there are some laws that guide some operations in mathematics when it's dealing with indices. So next, we'll be looking at some crucial laws in indices that will guide us to solve any form of real valued problem. So the first law we are going to consider is that if we have a raised to the power of m times a raised to the power of n. Now, by these laws, when you compare this expression and this, you will now discover that a is an integer and it is multiplying itself, and they have their index m and n. So this form an indices. So they have the same base. You pick one of the base, and because it is the multiplicative law, what we do is to add the index m plus n. That is, whenever we have a problem before us, if we can express that problem in the same integer, so we can successfully add the index, and that will result to the answer we're looking for. So the next law is given by a to the power of m divided by a to the power of n. If I have any problem in math and it assumes this form, they have the same base, what I need to do is just subtract the index if the integer is the same, meaning that a to the power of m minus n. And the third law is a raised to the power of n or raised to the power of n. Now, by this law, we can simply multiply the powers, and that's the result. Isn't that very easy? A raised to the power of m n. And by the time we solve this, we'll get a real valued problem. And also, we have other laws that we need to check. They are very important. What if I have an expression that a raised to the power of m all over a raised to the power of m. Now, if you compare this and this, they are almost similar. What differs is the expression of this divisor sign, but they are similar, meaning that I can decide to express this as a raised to the power of m divided by a raised to the power of n, and it assumes this form. And whenever I said if we have a math problem, they have the same integer, what we have to do is to subtract the powers. So this will lead to a raised to the power of m minus m. And any number subtract by itself is 0. So a raised to the power of 0 is what we'll assume. And any number at all raised to the power of 0 is always equal to 1, except 0 raised to the power of 0, which is undefined. But any number raised to the power of 0 is equal to 1, except 0 raised to the power of 0. Please take note. Right, from what is on the board, these are some problems that can be solved using indices. Now, we can easily solve any of the problem. I will solve some of the problem and I'll allow you to solve some of the problems. Like from question number 1, you see, first we can decide to make this integer and this integer to be on the same base, meaning that I can express 4 as a power of 2 and 8 as a power of 2. So if I successfully do that, then I'm going to apply the law of indices. So 4, I can decide to express it as the power of 2 raised to the power of 2 multiplied by 1 over 2. Then times 8 is 2 raised to the power of 3 multiplying 1 all over 3. See, then from one of the law that we have a raised to the power of m close bracket n, we said we can represent it as a raised to the power of m times n. So I'm going to use this law to solve this. So 2 raised to the power of 2 times 1 over 2 times 2 raised to the power of 3 times 1 over 3. Let's go gradually. So here we have 2 raised to the power of 2 over 2 times 2 raised to the power of 3 over 3. So here becomes 2 raised to the power of 1 times 2 raised to the power of 1, which is the same thing as 2 raised to the power of 1 plus 1, which is equal to 2 raised to the power of 2, which is 4. So that is the solution of this problem. Now, this second question is that of an indices that involves an equation. So how do I solve this problem? So what I need to do is to raise up to make this base the same. Is to make the bases the same, and if the bases are the same, what I mean the bases, the integers, they should be raised, they should be the same. So when the bases are the same, then I'm going to equate the powers. So you see, what number will I raise to the power that will give me 32, and what number that will be the same base to this also, if I raise it to the power of some number to a particular index, it will give me 8. Obviously 2 is the number. If I raise 2 raised to the power of 5, it will give me 32. So 2 raised to the power of 5 multiply h is equal to 2 raised to the power of 3 is 8. So from one of the laws that we have recently seen, we can decide to represent this problem as 2 raised to the power of 5 times h is 5h is equal to 2 raised to the power of 3. Now you see that the left hand side of this equation and the right hand side of this equation have the same integers, 2 and 2. So if you have a problem of indices involving equation, what you need to do is to make sure that these bases in the left and the right hand side of the equation are the same. And if they are the same, you can go ahead and equate the powers. So 5h is equal to 3 and h is equal to 3 by 5. Good. This is another form of problems involving indices. Now, you see, this particular problem is we can decide to express this in another form. If you have that 1 all over a, it can be expressed as a raised to the power of minus 1, where a is assuming to be 27, and this minus is this, and this 1 is 1 over 3. So we can express this particular problem in this form, but we have to be mindful of this power here, this index. So we can represent this as 1 all over 27 raised to the power of 1 over 3. And since we can express it as this, and we know that 27 raised to the power of 1 all over 3 is also equivalent as, is equal to, rather, 1 all over the cube root of 27. We can also express this so that our answer 1 all over 27. So when you impute this in your calculator, you will now find out that the cube root, 1 all over the cube root of 27 will give you an answer. Right. So 1 all over the cube root of 27 is 3. It's 3. So our answer is equal to 1 all over 3. When you simplify this problem using the laws of indices, you should arrive at 1 all over 3, and we have successfully solved this problem. So you can go ahead on your own and solve this problem on your own, and decide to share the answer by commenting under this video. So next, we shall solve one more question, and we are gone for this subject. We are going to solve this particular problem, which is next in line. Now, this kind of problem in indices, you need to be very careful, because this type of questions requires you to be very careful when using indices in order to solve. Now, this problem is going to land us into a quadratic equations that which we are going to solve, because when you look at this particular problem on the board, it's a quadratic equation. It's a quadratic equation in the form of indices, meaning that indices problem that will lead us to a quadratic equation. So we are going to use our knowledge that we have learned previously on the laws of indices and solve this particular problem. So come with me. So in order to solve this problem, first we need to break this. We know that from what we have learned that we have 2 raised to the power of 4 all of x minus 2 raised to the power of 2 of this x, 6 into 2 raised to the power of x plus 2 raised to the power of 3 is equal to 0. And from this law, we can decide to interswitch the powers, because we know that 2 times x and x times 2 is commutative. Since it is commutative, we can decide to switch them, meaning that we can decide to write 2 raised to the power of x raised to the power of 2 minus 6 into 2 raised to the power of x plus 2 raised to the power of 3 is equal to 0. So you see, this and these now are having the same form. So in order to solve this successfully, we are going to say let 2 raised to the power of x equal y. So whenever I see 2 raised to the power of x in this particular equation, I'll substitute y to it. So when you check here, we are going to have y raised to the power of 2 minus 6 y plus 2 raised to the power of 3 is 8 is equal to 0. So we have y squared minus 6y plus 8 is equal to 0. And this has led us to a quadratic equation. And there are methods in which to solve quadratic equation, which I have dropped recently on my tutorial videos, so follow up and learn. Thank you. Right. So by a way of revision, we are going to solve this quadratic equation using factorization methods. Like I've said, I have a video that I've dropped already on how to solve quadratic equation using the various methods. So by a way of revision, we are going to solve this problem using the factorization method. Factorization method, we are going to see that what are the two factors that will replace this middle term. Now, what I used to do first, if you multiply this term by this last term, you will get the value. Right, so solving this, we are going to have that y squared minus 4y minus 2y plus 8 is equal to 0. So if I have this, I'm going to group them so that I can have that y squared minus 4y minus open bracket 2y minus 8 is equal to 0. What is common to this bracket is y, so I have y minus 4. Now I'll divide what can go into 2y and 8 with no remainder is 2, so that I can have y minus 4 equals to 0. The brackets must be the same. So what is outside is y minus 2, and what y minus 4 equals to 0. So y minus 2 is equals to 0, and y minus 4 is equal to 0. So here y is equals to 2 and y is equal to 4. So I'm going to substitute back into the previous equation. Don't forget, we let that 2 raised to the power of x is equals to y. So for the first case, this one, so I have that 2 raised to the power of x is equals to 2, and 2 is the same thing as raised to the power of 1. So the base are the same. I'll equate the power, so x is equal to 1 in this case. So when y is equals to 4, I have 2 raised to the power of x is equals to 4. So 2 raised to the power of x is equal to 2 raised to the power of 2. Their bases are the same. I'll equate the power, so x is equals to 2. So x is equals to 1 and x is equals to 2 is the solution of the initial problem. Please, if you have any question, you can ask in the comment section. Please remember to like, subscribe, and share this video. Subsequently, I'll be uploading another video on log reading. Thank you.